All right, let me get my notes. All right. I feel like I haven't been at school for like 2 weeks. And I really wasn't sick. I started getting sick Sunday, but I was sick after that. So. All right. So tell me again, what are we doing more than this? We already did this, right? We talked about the mole. And here, did we do that one? Right. Oh yeah, y'all did that. And molar mass. All right. We'll move through one of these kind of quickly because we use molar mass a lot. So jug alone, and it likes to give you a little story. You'll find out on these problems. So they don't want you just to get the chemistry, they want you to get the history. But basically, that's my formula right there. I'm going to work the molar mass out long ways, but probably you're at that point where you can almost do it in just your calculator, especially when it's those common elements, you know, that you're kind of familiar with. But here, if I did this, I have carbon and I have 10 atoms. And I'm going to multiply that by its molar mass off the periodic table, which is 12.01. And then my hydrogen, I had 6. So I'm just multiplying through. And then my last one, I have oxygen, 3, and we always do that as 16. So 48. So that's the mass of all elements. I just took their molar mass and multiplied that by how many atoms they have. And then the last step is adding them all up. So 174.16. And this is where we have grams per mole. I think y'all's table is, no, yeah, 2 places past the decimal is kind of what, that's exactly how y'all's is. It is 2 places, the one that y'all will be using. So remember, this is what we end up using as conversion factor. We just tend to write it as that way when we use it in dimensional analysis. All right, y'all remember that? So then the next one says we have a 1.56 times 10 to the -2 gram sample of juglone. And it wants us to calculate the number of moles of that present. So we're just taking our grams and we're converting it to moles. So some of y'all will get so used to this that you won't even kind of have to write it out. I'm kind of a visual person, so I tend to write it out, even though it takes a little bit of time. Just gonna get this out of the way here, and I can do it right there on the side. So I have 1.56 times 10 to the -2 grams. And I want to convert it to moles. Notice it doesn't say how many atoms, so no Avogadro's number. So I just use, if I'm grams here, I have to be grams down here. And then we figure that up. So that would be 174.16 grams per 1 mole. If you're going from grams to moles, your number should get smaller. If you're going from moles to grams, your number should get larger. Because one is a division problem, one ends up being a multiplication problem. So top divided by the bottom, and you get 8.96 times 10 to the -5 moles of juglone. Remember, I'd have to have at least 174 grams to have even 1 mole, and we had much less. So that makes sense that it's that small of a number. I could then take that and to find out how many atoms I have, would use Avogadro's number, and would that be a multiplication or a division problem? Multiplication problem. All right, I'm gonna give y'all a minute. Y'all try the next one, A and B. Have to write your own formula. Oh, yeah. And since y'all all have your ion, oh, I did, yeah. Since y'all all have the ions memorized, I should be able to do that. Calcium carbonate. Oh, it has a formula? Oh, up there in the reading it does. And I will say this, AP chemistry test is actually pretty decent about giving you the formulas. Did I have y'all join Google Classroom or not?
Yes.
We did. Okay, let's do this one and I'll look it up. I didn't remember doing it. But that doesn't always remember. Excuse me. So that should have been the molar mass you came up with. I think they used just 100. 100.09. So our first one was the easy one. We just want to get it to grams. So before we had done a division problem, this one would be our multiplication. Once again, I realize most of y'all may choose to do this just straight in your calculator. For some reason, I like the comfort of writing it out. So we got 486 grams. Our number got larger. The second one was a little trickier. Was anybody able to get the second one? All right. So on that one, you just kind of had to say, because it asked you how many ions were present. So you just kind of had to dissect calcium carbonate. So if I have 4.86 moles of calcium carbonate, and what we were trying to find was grams of the carbonate ion, right? So our first thing, if we're moles of calcium carbonate here, we have to be moles of calcium carbonate down here. So you would say in 1 mole of calcium carbonate, how many carbonate ions would I have? This is 1 mole. How many carbonate ions are in there? Just one. And if it could have been the same thing if they would ask me for calcium in this case, right? And then you would have said for 1 carbonate ion is mass, so that's 3 oxygen and 1 carbon would give me 60.01 grams. So my units cancel. And then I would just multiply across. And there's only 1s down here to divide it with. And I should not keep on doing this. So that's where I got my 292 grams of my carbonate ion. Did y'all approach it a different way? Anybody approach it a different way? Oh, okay. So since this one only was made up of 1 calcium ion and 1 carbonate ion, if it would have asked me, you know, how many grams of calcium, I still would have had a 1-to-1. We're just still breaking that up. If it was an covalent compound, it wouldn't ask me for ions, it would ask me for atoms of that. So just a little bit different way of looking at it. All right. Next one goes back and talking about molecules and talking about atoms. So that tells me that I'm going to have to use, you know, Avogadro's number again. Oh, I don't even think that one. I'll do it right here. So this is number 7. Something that's responsible for the sin of bananas, in case you were wondering. Can be produced commercially. I feel like it's produced commercially a lot because I think there's a lot of fake banana smell. Bees release it, and when they sting. Okay, all things that will be tested on tomorrow. History. Calculate the number of molecules of isopentyl acetate released in a typical bee sting. So in parentheses, it tells me in grams how much is released in each bee sting. So it's 1 times 10 to the negative 6 grams. They originally gave it to me in micrograms and they changed it to grams. So that makes it a little bit easier. And what I'm trying to find is, what am I trying to find? The how many molecules are in that. So once I see that molecules, that tells me that I'm going to have to use Avogadro's number. So the first thing that I'm going to need to do is I'm going to need to convert my grams to moles, because that's how we use Avogadro's number per mole. So I need to take my grams, bless you. So the conversion factor we use to get grams to moles is always going to be the molar mass. So you would have had to figure out the molar mass of that compound. 7 carbons, 14 hydrogens, and 2 oxygen. And if you did all that, you would have got 130.21 grams per 1 mole. And then I just keep on following my units here. I'm moles here. I have to be moles down here. And once again, I see Molecules, that's one of my particles, so that's where my 6.02 times 10 to the 23rd molecules per 1 mole. Then you would multiply across and divide by what's on the bottom. You should come up with a pretty large number. Only one sig fig. To me, the fewer sig figs, the harder. So that's one thing. I'm 5 times 10 to the 15th molecules. What your final answer should be. Six. Oops. So in your calculator, you've got something like that, 4.6 times 10 to the 15th. Okay. Thanks. You're welcome. So in your calculator, excuse me, I'm sorry, y'all. Some 4.6 something went on, but anyway, since we can only have one sig fig, then that's where you got the 5 from. They give you leniency on the test. If you would have put that, you still would have been fine. They give you like a leniency both ways on the sig figs. And then the other part of it was calculate the number of carbon atoms present. So that's kind of like the one that we did with ions, but now since we're talking about a covalent compound, so I know this was supposed to be molecules, right? So I know I have 5 times 10 to the 15th molecules. So molecule is 1 unit. And that little amount of grams. And then I would say in 1 molecule, how many, what are we looking for? Carbon. How many carbon atoms are in that 1 molecule? 7 carbon atoms. And then you just multiply across. And once again, I think you get 3.5. This time I wrote it down, times 10 to the 16th. But because of that 5, that's how it becomes 4. 10 to the 16th atoms. So when we did stoichiometry in Chem 1, obviously we just stuck to the, like the 3 basic kinds that were, but I mean, stoichiometry can be used a lot. It's hard to just line every single one out that can be used. So sometimes you have to kind of just use a little bit of sense of what you know about formulas to get through some of them. All right. Any questions on those? Once again, you're not going to see anything but average atomic mass on the little quiz tomorrow. It's big, I think there's a way to make this bigger. Did you already show me how to do that one time? Yes. Yeah. Dot, the top right. Over here, above the line. Here, there. Yeah. How's it get small? That's right. That one was what I was trying to think of. Okay. I'll probably ask again for the years out there. So be patient with me. All right, are we here? I think we're here. All of that, I don't think I changed one bit. Anyway, so now we're talking about molecules, elements. This is molecules. We know our diatomics, your Brinkelhoff, Remember, when these elements are all by themselves, they exist as two atoms. Not when they're part of a compound. And so that affects sometimes their molar mass, because if they're all by themselves, you have to figure them as two atoms, not just one. There's also some other ones you don't see as much. Phosphorus is tetraatomic. And then sulfur has 8 atoms together when it's all by itself. Once again, we kind of don't see those as much as you do some of the other ones. Molecules is really for covalent compounds. Technically, although we tend to use it almost with any kind, but if you see molecules or molecular weight or anything with molecules, you should be thinking non-metal, non-metal. All right, next one is percent composition, which is really easy. As soon as you just probably need to refresh your memory a little bit. Does anybody remember doing percent composition? Where you figured out the percent of each element? So it's just a little bit of math. So whenever we're talking about different compounds, there's a couple ways to talk about them. Usually we tend to talk about how many atoms are in a compound. That's usually what we use to balance or for our stoichiometry. Another way that we don't use so much is the percent by mass of each element. And the percent composition says the law of constant composition states that any sample of a pure compound always consists of the same elements combined in the same proportions by mass. So we talked about that before. If I want water, it's always going to be 2 atoms of hydrogen, 1 atom of oxygen, or 2.02 grams of hydrogen, 16 grams of oxygen. So to get the percent mass, you get the mass, the total mass of the desired element divided by the total mass of the whole compound, and then multiply it by 100. So if you only have 2 elements in the compound, you just got to do a couple of calculations. The more elements you have in the compound, more calculations that you're going to do. You're always going to be dividing by the same denominator. What's going to change is your denominator. What's on top? I'm going to claim it. So I'm still not 100%. All right. So if we do this, consider ethanol, and there's my formula for ethanol. We're going to move on, and we don't do it really here, but this OH is an alcohol group. This is a hydrocarbon. This is something that you would see in organic chemistry. And an OH is the way that you would identify it as alcohol. And then there's a whole bunch of them to memorize for you, those of you that get to have the fun in doing that. Are y'all all of those? And I'm not going to lie, I knew all that stuff back then when I had to know it to pass, but I remember very little of it. So we would do a quick molar mass here. Like I said, you probably could do it in your calculator. I'm just going to do it this way. 2 times 12.01. That's for my carbon. Then I'm going to do my hydrogen. I have 5 here and another one here. So 6 times 1.01. And then the last thing I have is that 1 oxygen. So that's just 1 times 16. And all of that gives me 150.24 grams per 1 mole. Did you not find it wrong? Let me see. Did you see the? Y'all not have this one? Okay. I might just run right there. I don't know. Maybe I left a page out. Do y'all have this picture? Yeah. Oh, I left I don't know. I left a page out somewhere. So there's some notebook paper if y'all want to grab it up here, or if y'all see me do one, you may not need to. But if you have on top of that yellow thing. Sorry. So what we're trying to do is we're trying to find the percent by mass of each element. So remember, percent is always part of a whole. Oh, it's not written in the box. Is it just like it's stated?
Right below the formula for percent composition?
No, maybe I have two different sets of notes I copied around.
I'm just not there.
Okay,
I have H2O.
On there.
okay. All right, so to do that, you gotta always find the whole mass, and then you will start with just each element. So carbon, and I just like to get myself organized if I'm gonna do this. So for my carbon, I don't feel like this is right. Is it?
I don't think that math works out.
No, it doesn't, because it would, instead this math would work out with, let's try this formula, y'all. C10 H14O. Okay, sorry. And that would no longer be ethanol, and I'm not gonna lie, I have no idea what that is. Carbon. Oh, y'all had that one. Okay, let's go to that one. I think y'all have this one, sorry. I thought you knew the name of it. I was gonna be impressed. Elliot, you know the name of that one? Carbon, is that familiar to you? Not to me either. Would you like for me to tell you about it? It's a substance that occurs in two forms, having different arrangement of the atoms, but the same molecular formula and mass. All righty, now let's just completely step back and just regroup. I feel like I've been having to do that a lot today. I'm not gonna lie to y'all. At least whenever it's with y'all, it's bad. Whenever it's like my Chem 1 and I teach them something wrong, it's hard for them to regroup. All right, so let's start that again. For my carbon, I have 10 times 12.01. All right, then for my hydrogen, I have 14 of those times 1.01. And then for my oxygen, I have just one of them times 16. We all feel good about that. 150.24 grams per mole. At some point in time, I must have done this correctly because my answers do match. All right, now let's do that. For my carbon, let's look at each one separately. My carbon was 120.10, and I divide it by the total of the whole compound. And I multiply by 100. Yeah, right about 80%. And then I do my hydrogen, 14 times 1.04 would give me 4.14 grams. Still divide by the whole total, that doesn't change. Nine-ish. And the good thing about the multiple choice, when you can't use calculator, that works good that way. And then my oxygen, I only had one, so 16 divided by my total times 100, and I get my 10.65%. And if I add it up, it should be about 100, and this one actually does come to 100. So you're just looking at the part of each element its mass makes up for the whole thing. All right, why don't y'all try number 9? And it's a little bit longer because it has more elements in it. And see if you can get your percentages that match up in there. Oh, and then while y'all are doing that, I'm going to put the Google Classroom up here, maybe. So Glenn, that's the code for the Google Classroom, which you do need to join because I'm going to send you a couple of things through there. I'm just going to see who's in there. Oh, yeah, well, most people have it, so we don't use it that much, but when you have a chance, you might want to snap a picture and join that because if you were sick or something, then I could send you stuff through there.